if you have y, which is equals to xn, so when you find your y prime is going to be, you take this n down, you say x n minus 1. So this one, when you take it down, is like, for example, if you will have y equals to x to the power 3. So this means that you're going to take this 3 down here. It's going to be 3x to the power 3 minus 1, which is going to give you 3x squared. So when you see y is the same as we are saying f of x. So sometimes you might find the question saying, when you find, they can ask you that find dy over dx. dy over the x is the same as equals to y prime. So sometimes a question, it can say f of x equals to, let's say, 3x squared plus x 1. So when it's 3x squared plus 1, when you find y prime is the same as f prime like this way. So when you find f prime for this one, you take these 2 down. But when you take these 2 down, it's going to say 3 multiplied by 2. The 2 you take down, x to the power 2, you subtract by 1. But when you differentiate a constant, it becomes plus 0. If it's a number, or even if it was 3, it's going to be plus 0. Then equals to 3 times 2 is going to be 6. X 2 minus 1 is 1. So we can just write 6x. So if you have, for example, f prime of, so not f prime, f of x, which it can be 4x to the power 3 plus 2x squared plus 1. So if you have a function like this, when you get the f prime, your f prime of x is going to be equals to 4 multiplied by 3 x to the power 3 minus 1 plus again 2. This is this 2 multiplied by 2 again. That 2 there is going down. X to the power 2 minus 1. Because here is a number, you just say plus 0. Then the final answer, you're going to say 4 plus 3 is going to be 12. 4 times 3 is going to be 12. X squared, 3 minus 1, plus 4. 2 times 2 is 4x. Then the rule, when you are doing them, as when you start practicing, there is no need for you to just say 4 times 3. You can just say, you could just say 3 times 4, same time you write 12. So this is coming from whereby the rule that I gave it to you, we are using y prime, which is the same as f of f prime, which is the same as dy over dx, which is equals to, if you are using your f prime, is equals to n x to the power n minus 1 if your y was what? If your y was x to the power n, which is the same as f prime f of x. So now this rule is coming from the limit. So you did about, maybe, or you haven't done it, you have a formula which says f prime of x is equals to limit when h approaches 0 of f of x plus h. minus f of x divide by h. So this rule, we use it to find f prime before. So a question they can ask you can be given, let's say for example, I'm going to delete here for now. You can be given a function whereby your function y equals to x squared. Let's use x squared. So according to our rule, we know that if we want to find our y prime is going to be 2x. So, but normally if they can ask you, they say, find y prime or f prime of x using the first principle. Using the first principle. So what you do when you find y prime or f prime of x using the first principle, you are going to say f prime of x equals to limit. You first write the formula. Limit when h approaches 0 of f of x plus h minus f of x over h. Then now we're gonna substitute where there is f of x plus h. F of x, remember our f of x equals to x squared. So we're gonna say this is the same as limit when h approaches 0 of what? Where there is f of x, remember is x. So inside x squared here, we are going to put x plus h, which means it's gonna be gonna be having x plus h, which is this inside squared, minus what? F of x is our x squared over h. So now this one will be equal to limit when h approaches 0 of this one here, we can multiply. This is the same as x plus h, x plus h minus x squared over h. So this is the same as also equals to, you can say limit when h approaches 0. So this step here, if you want to eliminate it, you can just go direct. If you can still multiply, one is x plus h, like this way, inside here. Then you're gonna say x times x is going to give you x squared. X times h is gonna be x h, x h times x x h, which is gonna give us plus 2x h times h is gonna be plus h squared minus x squared over h. So you will see that this will cancel with this one. Then you will be left with limit when h approaches 0 of 2x h plus h squared over h. So now when we're left with this, you can see that we can take out here h. So this is going to be equals to limit when h approaches 0 of h in brackets 2x plus what? Plus h over h. So now when we have this, we can now cancel this h with this one. Then we're gonna remain with limit when h approaches 0 of 2x plus h. So now because this h is approaching 0, also this h is going to be approaching what? 0. So normally we can say it in a wrong way, that is like this h is 0, but h is not really 0, it's just approaching 0. So now the answer, we ignore this h, or you say 0, but you're gonna have the answer of what? When we put 0 here, it's gonna be 2x. So which is the same as the one when we differentiate using the formula that I gave it to you. So this one is the same, everything that you're gonna do. If they say using the first principle, remember to use what this rule for limit f prime of x. This is the rule for the first principle, f prime. This is the formula, f prime of x equals to limit when h approaches 0 of f of x plus h minus f of x over h. So this is the first rule. So if we check in the questions here, it says find f prime of x from the first principle. You see, from the first principle, if f of x equals to x squared plus x. So we have x squared plus x. So now if I have to find using the first principle, for f of x, we have a function f of x which is equal to x squared plus x. So before we even do the first principle, using that principle of ours, the formula, we can see that f prime of x is going to be, we take 2 down, it's going to be 2x plus what? When we take 1 down here, remember it's going to say 1x into 1. Here is 1 minus 1. So 1 minus 1, this one is going to be 2x plus x to the power 1. X to the power 1 minus 1 is x to the power 0. X to the power 0 is the same as what? 1. So 1 times 1 is going to give us 1. So now when we use our first principle, f prime of x, this is the one. You can just write this here, not in your paper. Just write somewhere in your draft paper if you are writing. You will know that, okay, when you are using the first principle, your answer must be this one. So now when you use the first principle, f prime of x, we know that we first write the formula, our limit when h approaches 0 of f of x plus h minus f of x over h. So now I'm gonna substitute what is inside x squared plus x. Then it's going to be limit when h approaches 0 of where there is x squared, we're going to put x plus h is gonna be x plus h squared plus again this plus x. Here where there is x, we're going to put x plus h again minus everything which is x squared plus x, which is going to be x squared plus what? Plus x over h. So this is the same as we're gonna say limit. We're gonna say as limit when h approaches 0 of what? We can simplify this. This one we know that is going to be x squared plus 2xh plus h squared plus again x plus h minus negative times x squared is going to be x squared minus x again minus x all over h. So if we take this out, you will see that it's going to subtract with this one. This one, it will be subtracted maybe with this one. So you are going to be left with, let's say, limit. Every time it's very important to write limit when h approaches 0. You're going to be left with 2 x h plus h squared plus h squared, 2xh plus h squared, plus again this h here, plus h over h. So if we take the h out, limit when h approaches 0 of h, outside we're gonna be left with 2x plus h. Here we are taking h, it's gonna be left with 1, plus again what? When we take h for this one, it's gonna be 1 over, is for this one over 1. So that when we multiply back, we get exactly this. So this one will cancel with this. Then we will remain with limit equals to limit when h approaches 0 of 2x plus h plus 1. So now if we put where there's h, we put 0, you're going to see that we're going to be left with 2x plus what? Plus 1, which is exactly the same as the one that we first wrote there using the formula. So it means that if you first use the formula, then when you use the formula, you don't write this in your paper. You just write it in your draft paper. If then after that, or you can write it with a pencil, you erase it. Then after that, when you use your limit, this formula for the limit, then you can see that you're getting the same answer. Then you erase with your pens, with your eraser. Then this is what how you do it when you use a first principle. So this is what we did when we are using the first principle is 5 marks. Then it will say determine f prime of x if f of x. When they say determine f prime of x without stating that you must use the first principle, it means that you are using that formula that I gave it to you. Then when you use it, you just say f prime of x, f prime of x equals to what? You take 5 down, it's going to be 2, multiply by 5, x to the power 5 minus 1, you know it's going to be 4, minus 3, multiply by 4, x to the power what? 3. Then this one here, when is x 8, let's say 8x, is the same as plus, you just write 8 only. Because here x, we know that is going to be to the power 1. 8 times 1 is going to be 8. You just write 8 only if you have 8x when you are differentiating. Or if you have 7x, the answer when you differentiate this is 7. When you differentiate this one, is going to be 8. One is x. So now, this one, you can just conclude that is 10. 2 times 5 is 10 to the power x, the power 4, minus 12, x to the power 3, plus what? Plus 8. So that's how. So that's how we do it. So the answer for f prime is going to be this one. So if you check it, when you differentiate, is like last time I showed you that if your tangent, your m, equals to 10 of theta, if you remember. So now when we say f prime is the same as equals to your gradient, equals to your gradient. But it's just that in this gradient, you can have a minimum gradient and a maximum gradient. So the question 7.3, it says, a tangent to the tangent to g of x, which is equals to ax cubic plus 3x squared plus bx plus c, has a minimum gradient at the point -1 and -7, for which values of x will g be concave up. So which values of x will g be concave up? So when we talk about the concave up and concave down, so when we talk about a concave up and a concave down, there are some rules that you need to know. We have a concave up. So in a concave up, when we take one value and substitute here, if it's greater than 1, if it's greater than 1, then it's going to be a concave up. And if it's greater than 2, it's going to be a concave down. So I'm going to write those rules here now. So if your graph, if when you're a gradient, let's say in terms of a graph, when your if you have a graph and your graph of f of x is going up, so and the slope or gradient, I'm gonna use m as a gradient or slope, is increasing. I'll just say showing with up there is increasing. So it means that this is a concave what? Concave up. But if your graph, you can see the shape of this graph. If your graph is going this way and your slope is decreasing, the m is decreasing. So in this graph here, we say this graph is concave. Concave what? Concave down. We say that this graph is concave down. So now, in order for you to know, to find a concave down and concave up, if a function if you have a function, okay, let me just give me 1 minute. So if you have a function, let's use this one. So in this function, it says the tangent to g of x, which is f prime of this, has a minimum gradient at the point. Okay, this for which value of x will g be concave up. So the first thing that we do here in g, we are going to differentiate g prime. We differentiate g of x. When we differentiate g of x, it's going to be 3ax squared plus 6x plus b. So when we have differentiated that, they say it have a minimum at what? At this value, negative values here. But sometimes you can take it further. When you want to know that the graph is concave up or concave down, if we differentiate second time again, these two lines here on top, they mean second time, we will see that our g of x is going to be 6, 2 is going to go down 6a x plus what? Plus 6 now. When it's plus 6, then if we make this equals to 0, you will see that when we take this 6 the other side, it's going to be CAX equals to negative 6. The negative 6 is the other side. Because of this A here, let's divide by 6 both sides because there is 6 here. We're going to have AX equals to negative 1. So in order for this to be, is AX equals to negative 1. So in order for this X here, if we substitute 1 here, negative 1 here, we will see that our A, when X equals to negative 1, we negative A equals to negative 1, then our A is going to be equals to 1. So now we've substituted 1 as the minimum. So, but this one here, you can see that if A was positive, and we get that X equals to negative 1, this means that this graph was going to be concave down. But in this question here, they didn't ask us to check that. They are asking us that it has a minimum gradient at the point here, for which value of X will G be concave up, for which value of X. So now what we do, when we get to this stage here, we are going to substitute these values, negative 1 and negative X, negative 1 and negative 7. So when we substitute those two values, negative 1 and negative 7, we got 3x squared. Let me write down. We have g of prime of x equals to 3a x squared plus 6x. Let me check if, yeah, plus 6x plus b. Plus 6x plus what? Plus b. So now, if I substitute where there is x, negative 1, I'm going to have 3a plus or minus 6, yeah? Also is going to be plus b, which is equals to negative 7. So this one here is going to be 3a plus b. We can take this 6 the other side, going to be equals to negative 7 plus 6, which is going to give us negative 1. So now we have this 3a plus b equals to negative 1. So if we take again g prime, second prime, the way I did it first time, then we get 6a x plus 6. Then this one here, you will see that in order, if we say equals to 0, or if I put 6a of, I put negative 1 plus 6 equals to again negative 7, you will see that we're going to have negative 6a plus 6 equals to 7, which is going to imply that negative 6a is going to say minus, is going to be equals to 1. It's going to be minus there, it's going to be 1. Then our a is going to be 1 over negative 6. So now if our a is 1 over negative 6, then in using this equation, we're going to see that 3, when we substitute negative 1 over 6 plus 6 plus b, this is b there, equals to negative 1. Then this is going to be negative 1 over 2 plus b equals to negative 1. Then our b, I'll write it this side, b is going to be equals to negative 1 plus 1 over 2, which is going to be negative 1 over 2. So now when we have these two values, if we substitute them back in our equation here in g prime, in g of x, you will see that your 3 over our x is was a negative 1, gonna be negative 1 over 2 x squared plus 6x plus, or we can just write it as minus 1 over 2. So now when we have this one here, if we put the value that in order for this, the value that of x, in order for this to be, what is it? In order for it to be concave up, we can also check the g prime second prime, that we're gonna have x plus 6 equals to, we can make it equals to 0. Then, but if we say x plus 6 equals to 0, our x is going to be negative 6. So in order for this, because here we have negative 1, it's going to be, when we start differentiate, it's going to be negative 1. So after that here, we can multiply by negative, then our x is going to be equals to 6. So in the value that this x must be in order for this function to be negative 1 is 6. The x must be equals to 6. So that's the value that we must do, you must have in order for your function to be concave up. So if we go back, which question paper is this? Let me see. Okay. Or 2022. So if let's check the value, we got 6. Number 7. So let me see how your memo is. Okay, the first one here, if you check, we did it the right way, exactly the way, this is how you write, the way I've showed you. And this one, you must take this one. This one is the simple form. And then the second one, we got this one exactly. So the second, this one here, we got the value that is going to be 6. So we got also our a was not 1. It was something like more than 1. It was, I can't remember, I will check there. But if you check here, the formula, the g of x is that you get the first thing you do, you will get the g prime, which is 3ax squared plus 6x plus b. We got this one. You will go to g second prime. We got this one also. Then now when we substitute in g prime for negative 1, yeah, we only substitute all the values. That's the problem. But if you substitute g of negative 1x, yeah, you will find that your a must be 1. So when the a is 1, for concave up, your graph g prime of x must be greater than 0. So when it's greater than 0, then 6x, if we substitute 1 here in this equation, you're going to have 6x plus 6. It must be greater than 0, when therefore your x must be greater than negative 1. So if I check here in what we were doing, just that the value that we got, they are not corresponding, because I solved all those values.
But then here we find that A is equals to 1.
Yes, yes. The problem here for me, when I solve A, I solve A in G prime in the second, in the what?
Oh,
In the second derivative. So the minimum, the A value, yeah, the way they state it, they say has a minimum gradient at point. So the minimum gradient, the gradient is at G prime, only G prime of X. So when the minimum is on G prime of X, so when you solve it, we're not supposed to, we're not in the second prime, G prime of second prime here. We're not supposed to, I was not supposed to put 7. So I was not supposed to substitute 7. So the only thing that we were supposed to do, we were supposed to, I was supposed to say in G prime, the first G prime we got, it was fine. It was it 3? Let me
yes.
check the bank
3
formula. Yes, it's gonna be 3. ax squared
plus
plus 6x, ne?
plus b
When we differentiate, no, okay, yeah, it's gonna be 6x plus b plus b. So this one here, the way we substitute those value here in this one was fine. So, but if we go to second prime of g of x, second prime will differentiate this one. When we differentiate this one, you're going to get 2 times this 3 here. It's going to be 6ax plus
plus
what? Here is going to be plus b. So this is the second prime plus this, no, not plus b. Remember, this
plus
is 6 here. It's going to be
a
6, is not b. It's going to be 6. So now in G prime, in order for us to get the what? To get the no that is concave, we have to find the value which is equals to 0. So if we substitute in G prime, we substitute negative x, negative 1, where there is x, because we have this called negative 1 and 7, negative 7. If we substitute negative 1 here, you will see that we're going to say 6a negative 1, where there is x, plus 6 equals to what? Equals to 0. So we're going to have negative 6a equals to what? Plus 6 going to be equals to 0, whereby our negative 6a equals to negative 6. We divide by negative 6, our a is going to be equals to 1. So here we don't substitute this 7. So I substituted the 7. That's why the value of a was wrong. So now when we get the value of a, we can substitute it back to this equation. So our g prime, second prime of x, is going to be equals to 6x, where there is a there, plus 6. So in order for a graph to be concave, I showed you that the gradient must be increasing, and to be concave down, the gradient must be decreasing. So it means that the g prime, second prime of x, it must be greater than 0 in order for a graph to be concave up. And in order for a graph to be concave down, the g prime of x must be less than what is 0. So for this one, because we are working with a concave up, it must be greater than what, 0. So when it's greater than 0, this 6 is going to go that size. Then we're going to have 6x is greater than negative 6. Then if you divide by 6 both sides, you want to have 6x is greater than negative what? 1. So that's how. So the only thing that you must remember is that you differentiate first, second time, then after that you substitute the value. So we're going to see this question again in the preceding question. So for the one I did there, this one I take it further. So I was doing something that it was not necessary. So you can see that we managed to work with the differentiation. So let's go to question paper for 2022 so that we can check the questions with differentiation. So this question I'm still gonna do with this one with you now. All these questions here. So this one says given f of x equals to 2x plus 2x squared minus x, determine f prime x from the first principle. So we are going to determine f prime x from is 2x squared minus x from the first principle. Our f of x equals to 2x squared minus x. So using the first principle, our f prime of x is going to be equals to limit when h approaches 0 of 2x plus h squared. I'm substituting x plus h minus again x plus h minus again 2x squared minus x. I write it as it is over h. So this is going to be equals to limit when h approaches 0 of, if we multiply this, you know that we're going to have 2 in brackets x squared plus, you must also remember that x plus h squared is x squared plus 2xh plus h squared, but you can work it out, minus x by this one, and minus h again, and minus 2x squared plus x over h. So this one here, you want to see that is limit when h approaches 0 of, you multiply everything by 2, you'll have 2x squared plus 4xh plus 2h squared minus x minus h minus 2x squared plus x. So you will see that this 2x squared is going to cancel with this one, and this minus x is going to cancel with this x, but everything is over h. So what we're going to be left with is going to be equals to limit when h approaches 0 of 4xh plus 2h squared plus 2h squared minus h. So we have written this one and this one and this one over h. So I can take out h here. Then I'm going to be left with limit when h approaches 0 of h in brackets 4x plus 2h minus 1 over h. So now this h will cancel with this h. Then we're going to be left with limit when h approaches 0 of 4x plus 2h minus 1. Whereby now, if we put 0 here, you will see that we're going to be left with 4x, where there is h, minus what? Minus 1. So if you verify, you can verify outside before. You can say, okay, let me check. If we use the formula, you can see that it's going to say 2 times 2. Your f prime is going to still be what? 2 times 2 is going to be 4x. And then when you differentiate x, you know that because it's 1, you write the sign here, it's going to be minus 1. So you see that we got it right. So you got it right. So that's how you verify that that you are doing it the perfect way. So we have done with that one. So then it says determine dx of x plus 1 in brackets 3x plus 7. So when you do this one, differentiation, when you have something like this, you can work it out using, we have something called a product rule, but you can also first say, for example, if you don't want to make mistakes, you can say this is equals to dx equals to, you multiply back everything there, it's going to x times x, 3x, gonna be 3x squared, x times minus 7 plus 3x, which is going to be minus 4x. I hope you understand why I'm writing minus 4. Is minus 7x plus 3x. 1 times 3x. 3x is going to be minus 4x minus what? Minus 7 again. 1 times negative 1. Then now this is going to be, because when you differentiate what is inside here, 3x, you know that is going to be 2 times 3 is going to be 6x. And then here there is 1 minus 4, because it's what? Is x is going to be 0. The way you just write minus 4. Where there is minus 7, there is no x, is 0. You leave it as it is. So the answer here is going to be dx of this. Yes, dx means you are differentiating to, is going to be 6x minus 4. You can see here, they say find dy over dx if y is that. So in the second one, you have y. You can first rewrite this as, remember the square root is the same as x to the power 3 over what 2. When you see square root of x is the same as equals to x to the power 1 over 2. So this one is going to be 3 over 2 minus 5, right? Minus 5 x to the power negative 1. When you have 1 over x, 1 over x is the same as x to the power negative 1. So I'm rewriting them properly so that you don't have a problem. Plus 1 over 2 pi. So pi is 3.4. It's just everything you see here from 1 over 2 is a number because pi is a number. So now when we differentiate, when we find your dy, because they say dy, you can write dy over dx is the same as y prime equals to, when you differentiate, you are going to take this down. It's going to be 3 over 2, 3 over 2 x to the power 3 over 2 minus 1. Remember, that's a formula. Then you take this down, negative 1 here is going to be plus, because there's negative times negative, going to be plus 5 x to the power negative 1 minus 1. Because this is a number, it's just going to be 0. We ignore it. Then it's going to be 3 over 2 x to the power. This one, 3 over 2 minus 1, you can use your calculator. But the answer that you're going to get there is going to be 1 over 2 now. Plus 5. Here is minus 1 minus 2. Minus 1 is the same as x to the power negative 2. So if you rewriting this, you can still rewrite it as, remember, this is a 1 x to the power, square root of x is the same as x to the power 1 over 2. You can rewrite back as 3 over 2 square root of what? Of x plus what? Plus 5. This one, because it's 2 here, you can write as x 5 over what? Over 2. Did you see what I did?
Yes.
So this is how we differentiate. This one was for 2017. So this is how we differentiate. So this is the final answer. You can even end here. It can still be fine, but you can write it in this format if you know properly, like to show that you understand maths. So this is how you do them. So the other one says given f of x equals to this, you have this function, and you have f prime of x, f of 1, f prime of 1 equals f prime of 2 equals to 0. Then you have f of 1 equals to 4. They say show that f has a point of inflection at x equals to 2. Where do you find the point of inflection? A point of inflection, you find it when you differentiate the second time. So if we take this function, we differentiate it. This function first, there is a rule that I wanted to teach you, but I'm not sure if it's according to your standard. I'm going to have to first show it. If you have these two things here, let's say, for example, you have x in brackets x minus 3x. The first thing that you do to find f prime of x, your f prime of x is going to be equals to, you first differentiate x. You can differentiate this x. You're going to be left with x minus 3x squared plus, now when you differentiate, you write x, you differentiate, you first write x, you differentiate what? When you differentiate x, remember it's going to be 1, né? That's why we don't write anything, we just wrote angle x minus 3x squared. When you differentiate x minus 3x squared, it's going to be in 2, you're gonna take 2 down, gonna say 2x minus what? Minus 3 to the power 2 minus 1 is going to be 1. But because here there is x minus 3 inside, when you differentiate x minus 3, it's going to be 1 minus 0. So it's like multiply by 1. We can just leave it as it is. So this answer now here is going to be x plus x minus x minus 3 squared plus 2x this 2x here, if we multiply 2x minus times this one, you'll see that we're going to have 2x squared minus 6. 2x times 3 is minus 6x. So you can still rewrite this as, we can change this one to be x squared minus 6x minus 6x is going to be 6x plus 9, and then plus 2x squared minus 6x. So this plus 2x, this one you can see that if we add this one and this one, we're going to have 3x squared. If we add these two minus 12x plus 9. Eh? So if we get second differentiation of this, of x, you'll see that we're going to have 3 times 2 is going to be 6x plus minus 12. So now, if I make this equals to 0 in order to check, when you want to find an inflection point, your second differentiation, you make it equals to 0. Then when you make it equals to 0, we're going to have 6x equals to what? This 12 is going to go there, is going to be 12. If we divide by 6, we divide by 6. Then you will see that our x equals to, our x equals to what? 6 divided by 12 divided by 6 is 2. So you have proven that x equals to 2. But this rule that I showed you, I think is going to be more confusing to you. So let's just take this in a very simple way that you can use. The method that you can also use, f of x is equals to x, in brackets x minus 3. I will first check if you must use that rule. I will teach you, I have to teach you that rule based on your standard. So this one here, before you solve it, you can first solve this x here. You write x minus 3 in brackets x minus 3. Ne? You are solving, then this is going to be x in brackets x times x, you know that is going to give you x squared. X times this is going to be minus 3, which is going to minus 6x. Minus 3 times minus 3 is going to be plus 9. Then you can multiply everything by x. Then we're going to get x cubic minus 6x squared plus 9x. So this is our f of what? F of x. So now when you have this, when you differentiate this one to find f prime of x, you can use the rules that I showed you. You just take down 3. It's going to be 3x squared minus times 2 here is going to be minus 12. Then x here is going to be plus 9. So if you find your f prime again, second prime, you will have 2 times 3 is going to be 6x minus what? 12. So now because you want to find an inflection point, you make your second prime to be equals to 0. Then your 6x minus 12 is going to be equals to 0. Then which means your 6x is going to be equals to 12. Then you divide by 6, you divide by 6. Then this implies that your x is going to be equals to 2. You have proven that x equals to 2. It's an inflection point in the graph. So now let's check the question. So this one here, we're still going to cover them. I just want you today to focus more on differentiation. Then we're still going to cover how to sketch everything there. And this one is 2017. It's nice. So after understanding the differentiation, the cubic functions, they won't have a problem. You won't have a problem with them.
Okay.
So let's check. We have 2021 November here. So this time now you are going to be the one doing it. because I've already told you everything that you need to know about differentiation. So I have to see if you can apply what I taught you. Is this question paper you can see is Mathematics P1, November 2021. You can download it in your site. Then I'm going to tell you which question number you're supposed to do. So remember, the standard is going to be the same, but the way the questions they might not be the same. So I want you to do question number 9.
Okay.
Only question for today, you are not going to do much. You're going to do 9.1 and 9.2. So don't check the memo, don't download the memo, because I will see when you download the memo, it's going to be the same or. So I want you to see how you are writing is better. You write and you fail while I'm still teaching you rather than failing in the exam, in the classroom when you're writing your exam.
Mm.
Yeah.
Only question 9.
Question 9 only.